If you planted a seed on Mars, would it grow?
Can astronauts use the computers on the International Space Station to play video games / go on the internet?
Would you rather be an alien or an astronaut? Hello and welcome to Space Now, the space news podcast from the National Space Centre that goes beyond the headlines. I'm David Southworth.
And I'm Josh Barker.
Now today is another Mailbag episode. It's been quite a while since we've done one of these. They always make me a little bit nervous, but once again, we are going to be taking your questions that you've sent in very kindly, and we're going to be taking them blind. We haven't seen these questions in advance. Josh and I will be doing our very best to give you good answers to them. So let's start with our space wows. These are things that we've spotted in the news recently that have caught our attention. Shall I go first?
Take it away.
Okay, so my space wow is a news story I saw a few days ago that Perseverance, the Mars rover, may have spotted an object called 3I Atlas.
Right.
Now we've mentioned 3I Atlas on the podcast before. It's an interstellar visitor. It's a comet. We think it's probably the oldest object we've ever seen in the solar system. 3I it's because it's the third ever interstellar object, so confirmed object from outside the solar system. It's an interstellar visitor. Now, we know it's been moving around the solar system. It's been detected from things you'd expect, like the Vera C. Rubin Observatory, an incredibly powerful telescope on the Earth. James Webb Space Telescope, Hubble, they've both viewed it. But recently, it is thought that the Perseverance rover on Mars spotted it.
Okay.
Now, there's a couple of interesting things I think about this story. One is the idea of this almost like a collaboration between different sources. We're not just putting telescopes looking at this thing.
Yeah.
Perseverance takes photos as part of its just operations. And one of those we think has this object in it. But also there's other spacecraft, JUICE and the Europa Clipper, both currently on their way to Jupiter's moons. They're apparently going to be trying to take a look at this object as well. I guess
if you're up there in space, you might as well, if you've got some sort of instrument that could take an image.
So JUICE and Europa Clipper particularly were never intended to be looking at random space rocks. They're going for a particular mission. But they're able to use those instruments and have a look because we want to learn as much as we can about this object. So that I think is incredibly interesting. Second part of this story that I think is really interesting, and I'm afraid as ever, I'm going to bring some US politics into this.
I mean, it is our theme, it seems.
Exactly, well, it's my theme, yeah, it is. So normally I think NASA would have confirmed this. There's been speculation online that this object in Perseverance's photo that was released by NASA is 3I Atlas, the object we think it is. But NASA haven't done that. And the reason is that there's currently a US government shutdown. So basically, all sorts of political wranglings, the budget has not been agreed. That means a whole load of public services shut down. It's quite different from how we do in the UK. And so NASA, I'm not sure exactly the details, but I think I read that up to 80% of NASA's employees are currently furloughed.
I saw similar numbers,
So NASA is currently hugely understaffed. So there hasn't been any official statement from NASA on this. It's a streak in the picture that's released. So there's speculation that it must be a composite of several images over time, because if it's a snapshot, it wouldn't appear as a streak, it would be a dot. So I find that very, very interesting that we think Perseverance has spotted this incredibly interesting interstellar object, but it hasn't been confirmed. So that kind of adds to the mystery. So that's my one for this week.
That's pretty fascinating. I quite like that one.
What about yourself, Josh?
So mine is that super puff planets may completely change our understanding of how planets form.
I mean, I'm tempted to ask you to just leave it there and we can leave it to our
just
imagination.
Go on, no, so this is a recent discovery of this new type of planet called super puff planets.
I've not heard of these.
No, fantastic name. The official planet name is much less interesting. It's TOI 4705b or something like that. So, named after the instrument that found him and the number that's there. Yeah. But essentially, these are giant planets that don't weigh much. So this planet that we're talking about is about the size of Jupiter. But it weighs about a tenth as much. So in terms of the material that makes it up.
So its density is incredibly low.
Incredibly low, and that's where the puff comes from. Super, generally in space, when it comes to planet, means big, but the puff sort of element that it's indicating is that these things are super low density. So it's mainly just wispy gas.
Do we know why? And do we know anything about these yet?
Not really.
But it's an interesting new type of planet we've not seen before.
Yeah, it's an interesting new type of planet that we've not seen before. And basically, we're unsure. So we know that often planets that are close to the sun heat up, and that causes them to expand. That pushes out the energy, lets the gases get bigger, stretch out. But this planet's not close enough for that to happen. So that's a bit odd and a bit unusual. It also could be potentially rings. So that's the other thing, is maybe we're not seeing a large spherical planet, but we're just detecting the edge of these rings.
Okay, yeah. Yeah, so we're seeing what we see a round object and actually make this ring.
But actually it's just rings.
Okay, yeah.
Except the planet's too warm for that. So usually you expect rings around cold planets, and this one's too warm. And so we're not really sure. So we've found this object. We've sort of got an idea of what's going on, and we're desperately trying to figure out what's happening. So the next chapter in that is actually to look using the James Webb Space Telescope, which has got this amazing ability to understand what things are made of. And because of this thin atmosphere that's hopefully spread out, the James Webb Space Telescope should be able to get a really good view of what it's made of. And that might start to give us an indication of what's going on. But as this is a new planet, we're now going to have to wait for those images to be taken. But yeah, we've got this bizarre and unusual thing that's out there that's orbiting in completely the wrong position. Normally things orbit around the equator of a star. This one's going over the North and South Pole. It's just every measure is not what we'd expect from a planet. It doesn't fit with our understanding that we've got from our own solar system and exoplanets, and it's just sort of come along, and it's weird and unusual, and we still don't really know why.
So it's currently just confounding all our understanding, but if we can work out what's going on, that could give us some really good extra new knowledge that we didn't
Fingers crossed.
have. Watch this space. So on to our main focus this week, which is our mailbag. Again, we're going to be answering the questions that you have sent in. Shall I get it started?
Go on, do the honours.
Okay, we've got them randomised here in our mugs. So let's see what we've got.
Looks like a chunky one.
Right. No name on this one, so anonymous, I'm not sure who sent this in. If you planted a seed on Mars and cared for it, would it grow?
That is an interesting question. I think the easy way out of that is it depends on what seeds. You know, some seeds grow in certain places down here on the Earth, some don't. But I think what the question's alluding to is, could we grow stuff on the surface of Mars?
So my first reaction was a straight no. Because most of Mars is too cold. I suppose bits around the equator are warmer. Liquid water doesn't survive in a stable way on Mars. The pressure's too low. So it seems to me that the initial answer is that the conditions wouldn't support plant life.
I think that's correct.
The caring for it would be too extreme for us to actually achieve, I think.
Yeah, I guess depending on how extreme you go with your caring for it.
You'd have to fertilise
that was what I was going to say.
regolith, wouldn't you?
If you took fertiliser along with you and did that as part of your care regime, that might help. If you cared for it by building a greenhouse to bring the temperature up and provide an atmosphere, then that would help.
So building a greenhouse, I would imagine, I was going to say definitely. Let's stick with that. I think you definitely could manage it if you had a base and you built a greenhouse, because you could then have a controlled environment. And you'd have your fertilisers to grow it in. Yeah,
and I was going to say, I think actually what this question really comes down to is, what's the soil like? Yeah. And I don't know. I know so we've been doing lots of experiments. Obviously, Mars is hopefully the next destination for humans once we've been back to the moon. It's certainly one that's capturing the imagination. And that idea of the problem with Mars is it's so far away that we need to have a long-term survival goal. And so growing food is a key part of that.
A vital part of our sustainable existence if we were to go there.
But that requires effort. If you've got to build a greenhouse, if you've got to take fertiliser, you've got to take water, all of that's extra stuff, which makes it more difficult. So I guess really what's really at the heart of this question, I think, is what's the minimum we need?
Yes.
And I think we definitely would need a greenhouse. The atmosphere is too thin. It's not warm enough.
So the basic question, if we take it as if we plant it in the Martian soil, the regolith, we're saying no, it wouldn't grow.
That's what I think as is, Mars as is, it wouldn't. If you took a greenhouse, I'm not sure. I know that we need, certain evidence that we've had is that we do need certain key minerals and nutrients for some things to grow. I don't know the current state of the research, if there is anything that would grow in the Martian soil as it is.
No,
I don't think there is.
I've got a feeling I have read stuff that there are some of the right kind of nutrients we think we've detected in that Martian regolith, but probably not enough to sustain that, as you say, without
that's my understanding help. And I think basically the real answer is no. You'd need to basically take a whole environment, not only
I think so.
Oxygen, water, temperature equipment, but also that key fertilizer.
So
I don't think it's on
its own. Creating your own soil. So if we planted it in the Martian soil, covered in a greenhouse, with some fertilizer, it's a maybe.
If you take everything you need, probably.
Then you probably could.
But I don't think the soil itself is fine as long as it's warmed up or something like that. Unfortunately. Shall I go for a question?
Why not?
Okay, let's have a little look. So this is a long one here. So this one is from Sam, and it says, I know we see things thousands of years after they've actually occurred in space, but are there any examples of us actually observing changes as they happen? For example, has anyone ever sat and watched a supernova, or do we just work out what's happened by observing before and then after?
Okay. My first reaction is yes, I think we have. The one example I can think of, and it's maybe not quite watching it in real time, a supernova that was observed in, I think, the 12th or 11th century in China by some Chinese astronomers, which I think became the Crab Nebula.
I believe so, yeah.
And the Crab Nebula is what was left behind after that supernova. So, from what I recall, they saw not the explosion as such, but what they saw was the super bright object in the sky. And looking back with the benefit of what we now understand about how these things operate in space, where it is in the sky, because it was recorded quite accurately, we now know that to have been the supernova that led to the Crab Nebula.
Yeah.
So that does mean they saw that event, but they certainly didn't understand at the time that's what they were watching.
Yeah, and I think that's the problem, is that often a lot of these things happen over a long time scale. So even like a supernova, which is an explosion, which we think of as something that happens, you know, if an explosion happens down here, it's over in a matter of seconds. And you might get maybe 30 seconds of aftermath of clouds and stuff like that. But even in space, these distances and timescales are so huge. So there's another really great example, one of my favourites. This is a series of images from an object called V838 Monocerotis.
Okay.
It's a bit of a mouthful. But that's, again, same thing, a giant star that gave off a load of material. I can't remember if it went fully supernova, but it definitely gave off a load of material. And from about, I think it was 1989, 1990, through to the 2000s, we've been able to go back and take several pictures. And there's some really cool, like, stitching together, like, GIF animated images showing this cloud of gas slowly getting bigger as it's spreading across thousands, you know, hundreds of thousands of miles of space.
Was it Hubble that took those pictures?
Yeah, so Hubble's taken some,
sense.
and I think a couple of other telescopes have gone back and looked, and it's really interesting because you literally see the latest image.
So you can actually see the movement. Yep. Okay, so that's a much better example.
Yeah, so that's. But again, it's not real time. We didn't sit and watch it because took
it still happened
30 years,
whatever,
for it to spread out. So yeah, and I think that's the thing. We can observe things happening in real time.
Yeah.
They're delayed because of the nature of.
So we're still seeing them thousands or hundreds or tens of years later, depending on how far away the object is. That's unavoidable. We can't see them any sooner, but we are. But we can, if we're lucky, able to see that occurring in real time.
Yeah, the light is continually travelling. So although it's 1,000 years delayed, you could sit in your garden and watch it, but just because of the nature of how far away it is and how difficult these things are and the time they take, you're not going to see much change, certainly on distant objects. But that being said, we do see things dynamically changing on things like comets. Yes, so when we get comets or asteroids moving through, you very regularly get almost real time, maybe a few seconds delay depending on how close they are to Earth, but you can watch these things.
And we've seen things like when the Schumacher-Levy comet collided with Jupiter, and we had some excellent images of the kind of the little explosions as it interacted with the atmosphere as it does, and even the surface of Jupiter as it crashed down into it. So that again is only a couple of minutes, a few minutes delayed, isn't it?
Yeah.
So that's close to real time.
Yeah, and I guess the other aspect to that is the technology behind it. We don't have a habit of sending up, HD video cameras to go and stare at stars into space. We just don't have the space infrastructure to do that. But as we get better and better technology, we'll start to see more of that happening. So at the moment, we see these snapshots because if you're taking a picture on Hubble, that image might take, the best part of 5, 10, 20 minutes. I think the longest exposure is something like 2 weeks on a Hubble image. This isn't a video camera that's capturing constant information. You have to have a gap, and you've got to balance that against, the million other things that people want Hubble to look at. So you can only look once every few years, perhaps. So it's balancing what we want to see and across that way to get a sort of real-time view.
Some good examples there, I think. Okay, this is interesting. This is from Stevie. What would happen if you poured water on the moon? So I've got my initial thought.
Yeah.
I think it would immediately start to evaporate.
Yeah.
Because it's kind of similar to when we were talking about the Mars situation with the planting the seed. Water can't exist as a stable liquid form in that pressure.
I think it would completely evaporate almost immediately.
What if it was absolutely loads? So if I had a cup of water, I took one of these cups with water,
that would immediately.
You'd take the lid off, it would start to evaporate, it'd be gone in seconds, if that. But what if we had a huge vat of water?
Now that's an experiment,
and we poured it, Could it start to freeze? Some of it could start to freeze in those temperatures before it's managed to all evaporate.
I'm not sure. I don't know.
Like a little mini Europa, an icy surface with some water underneath.
It would be interesting to see what a large scale, because instantly, small amounts. You're quite right. In the vacuum of space, even the lower gravity, it's going to fall a bit slower and all that stuff. But beyond that, there's no atmosphere. It's a vacuum. Yeah. It's going to instantly vaporize. But I don't know. Instantly vaporize. How that then scales? How much does that scale with? If you've got a barrel of water, is that enough that most of it evaporates? But some of it stays cool. So probably
at some point, you keep increasing the volume of your container. At some point, potentially, it takes long enough to evaporate that some of it might freeze and it might protect some of the water inside under that frozen surface.
Potentially.
But we're not sure how big that would have to be.
I'm also not
Bigger
sure.
Than either of us could tip out.
Yeah, I'm also not sure if the heat transfer would be quick enough, assuming you're coming from inside a spacecraft where it's, a balmy 20 degrees or something, and then straight out into the instant the instant vacuum and the really low temperatures. I don't know if the heat would leave quick enough that it could freeze before it would then vaporize.
You'd also have to be on the dark side of the moon for that, wouldn't you? Because it's too hot, I think, on the light side of the moon,
that would stop it from freezing.
So even that, if you could see what you were doing, it's evaporating.
Ultimately you're not going to see much.
It's not going to be useful.
I think most of it's going to disappear.
Yeah, I think we're agreed. Probably it's going to evaporate.
Yeah.
Okay.
Excellent. Let's have a look at the next one. So this one is from Jamie. Okay. Jamie says, I heard on the news, we like the news, we do. Going beyond the headlines, that there is a wall of fire that is thousands of degrees hot at the edge of the solar system. Can you tell us more about if that's true and what is happening there? Well, this is something that I think I've also heard talked about on the news and I think has been around. And I think this, my understanding, if it's the same thing I'm thinking of, is it came from a story about the Voyager probes.
Yeah, I've heard something about this. So I'm going to let you keep talking. The
Voyager probes. So the Voyager probes heading out of our solar system. So there were original set of probes in the 1970s that were looking at the outer solar system planets, so Jupiter and Uranus and Neptune. But they were sent on a course that would kick them out into deep space, so beyond the edge.
Both left the solar system, haven't they?
And that's right.
Through the heliopause.
Yeah, that's correct. So after about 40 years of travel, they finally reached roughly the edge. We still keep changing and adjusting what is the edge because we don't really know. And and I think there was a story that went around that when one of them, I can't remember which one it was, reached what we thought was the edge, it measured a really huge spike in temperature, which was very confusing. Space is cold and that we think empty.
Yeah, and that's a long way from the sun.
Yeah, and so people took that and said, there's all this temperature and there's all this energy. Does that mean there's essentially, a big shell of fire or heat trapping us in? I don't think that's true.
So what the little I recall of this, yes, I think it must be Voyager 1 because that's further away, isn't it? That's travelling faster and it got further away. But the temperature it detected wouldn't be a kind of a wall of fire. I think it would be, in fact, let's take this back. It wasn't us, it was Ed and Dara did an episode of this podcast about the Parker Solar Probe.
Yes, they did.
And I remember listening to that and a really interesting explanation I think Dara gave, which made things very clear to me about the difference between temperature and heat transfer.
Yeah.
That you can have a high temperature, which comes from the movement of individual particles.
Yeah.
But if there's not many of them, very little heat gets transferred.
Correct.
So that's why presumably Voyager 1, wouldn't have been damaged by that temperature. I think the same reason. Few and far between, but the particles that are there are moving super fast.
Yeah, if you detect one high energy particle, that could register as a particle at an extreme high temperature, but that doesn't necessarily mean that it's sitting in the room with you is going to keep you warm through the winter because it's one particle in, a soup of trillions of particles that might be much lower energy. So I think what probably happened is that Voyager detected an incredibly high energy particle that was, had a lot of kinetic energy, which then essentially it's moving quickly, which translates to what we understand thermal energy and temperature to be, but that doesn't necessarily, like you say, mean that there's an environment around it that is, suddenly the probe finds itself at thousands of degrees and melting or something like that.
So not a wall of fire,
no,
but some high temperatures detected. Now, I've now said everything I know about this story. Do you know anything about any theories about why this might be the case?
So I think the current understanding is, like we say, we're not really sure how the edge of our solar system works. And that's kind of why the Voyager probes are so exciting, because they're giving us a first-hand experience of taking these measurements and finding stuff out. We know that a bit like the Earth has a magnetic field that protects us from the sun also has a magnetic field that we think is doing a similar job. So is providing, you mentioned the word heliopause. That's essentially this shell that's created by the sun and its magnetic field that might protect us or interact with, whatever's outside of our solar system. And so it's trying to understand what those are. So maybe, as a guess, this is not my area of expertise here, but the Earth's magnetic field directs the sun's radiation around this shell. It creates the northern lights, which I think we've talked about a few times. Maybe the sun's magnetic field is doing something similar with some radiation sources outside. Maybe there's an area where all of this energy, all this radiation is following the lines of the sun's magnetic field, and perhaps that's what this area is. We go through a very narrow band where all of the energy is kind of directed.
Okay, so maybe even sort of focused into that narrow area.
Perhaps, yeah. I don't know if that's the case.
So all speculation.
But it's all speculation.
Hey, I'd buy it. That sounds feasible to me.
Excellent, good. Okay, so our next question is from, it's just from YouTube, so all of our lovely YouTube comments.
Okay.
And it says, can astronauts use the computers on the International Space Station to play video games / go on the internet?
Okay. I actually have a little bit of inside knowledge on this.
Excellent. We'll start us off then.
Yes, we both, I think, are aware they have plenty of computers. They have a good satellite link, giving them a really good internet connection.
Sure.
They use it for their work. They also use it to communicate, so that you can use it to call home. They have video calls, and they use it to tweet and to send Instagram pictures all the time and stuff like that. There's no reason they couldn't use that for video games. I suspect it might be slightly frowned upon. Certainly, kind of, if we're talking about big complex RPG that takes up loads of bandwidth, I'm getting out of my zone of comfort there. But the small bit of inside knowledge I have is that I've met Tim Peake once. I think you may have met him more than once. Is that right?
I think I've met him twice.
Yeah, I thought you had.
Yeah.
I've met Tim Peake once. Cut that bit out. He told me, he was talking to a group of school kids, and he told them that he once, with the crew that he was on the ISS with, they once had a half-hour Space Invaders session.
Amazing.
On, I think, maybe a big screen that they have there. I'm not sure what the detail was. So I believe the idea, certainly when he was there, which of course was 10 years ago now, coming up to 10 years ago, I think they weren't supposed to spend lots of time doing things like video games, but they certainly have done occasionally.
Yeah, well, they get some downtime to it. I know that they've watched things like sporting events or films. I think they regularly have movie nights on the space station to give the astronauts a chance to relax. So, yeah, well, it's interesting about unofficial video games they might not want to admit to. I do know there have been officially times when they have had to play video games.
Had to, as in part of research?
Yeah, so there was a really cool project called AstroPi. So people might know of the Raspberry Pi tiny computers. You might have heard of those. Yeah. So the organisation that helped set that up were really keen to get school kids involved in computer coding. So during a collaboration with the International Space Station, they sent up some AstroPis and some kits with some extra stuff on and challenged school children all across the United Kingdom to come up with computer programs that would do science and research using these systems.
And they tested them on the ISS then?
Yeah, so they had a really cool one that used the camera on board to look at forests and understand those. Some were using the gyroscopes and sensors to measure when the space station changed its altitude, and you could measure that. But one of them was a series of games to test reactions. So a bunch of school kids came up with a series of short games that would test reactions built onto a computer. So I think it hits the video games criteria. Totally. And the astronauts had to spend an amount of time, once a week or whatever, spending 10 minutes going through these games to gather the data to see how their reaction times change while they're in space. So that was really officially mandated space video game time that they had to spend.
So we know they have done some gaming. We don't know if anyone's doing any more intricate gaming. If you were playing a game online, could you be playing against an astronaut on the ISS?
I don't.
Maybe.
Yeah,
probably
maybe.
Not.
I don't know. Yeah, I don't know how good the connection is. I know when we've done link-ups at the Space Centre to the astronauts, I think you only usually get about 15 to 20 minutes before then the signal has to move to a different station.
Right, okay.
So if you were doing a streaming, it'd have to be quite a limited,
So you could maybe get a bit of Candy Crush going, just play for a few minutes.
About 10 minutes there. Yeah, maybe.
Okay. Okay. Light is the driving force for direction in plants' growth and not gravity. So, does this mean I can grow plants upside down on Earth too?
Okay.
That's a great question. That is from Conan, I think. It says on YouTube.
Excellent.
So I think we're saying there that... so I know they have grown plants on the ISS, and part of that is to understand how gravity interacts with plant growth. Again, we talked earlier about the need for sustainable plant growth with our Mars question. So that's helping us to learn about that. So I think the implication there is that if you put a strong light source, the plant will grow towards that rather than growing upwards in terms of our direction of gravity.
Yeah.
So if we put a really strong light source below some plants and planted them on a planter which allowed them to come out of different directions, would they grow downwards? That's a great question.
I think they would. I think like you say, I think from the research we've done with plant growth on the space station, that is just done using light, that plants can work out, well, not work out, they detect the light and can use that. And I think they do also use gravity, and I think it was on the Skylab space station as opposed to the international. That was the early American one. I'm pretty sure they did some experiments with rotating like planters to create artificial gravity.
Right.
So they had a force that wasn't gravity but simulated gravity, and used that. And I think they found with that the plants also respond. So
they respond to the still going towards the light, or
they would go. I think they were built such that the light and the gravity force were aligned, but essentially they created their own sense of up and down, so they could get them growing sideways by moving them at the right speed, creating a force and having a light.
Interesting.
So
we think the light does dominate that.
I think it does, but my understanding is that it's both are a factor.
So if we did, because the ISS experiment we're talking about, that's in microgravity. The ISS is in a state of microgravity. So let's say there is an interaction between gravity and the light. You wouldn't need super strong light source for that to become dominant.
Correct, I think so.
With essentially no gravity. Yeah. If you do it on Earth and you do have gravity, if plants are reacting to gravity as well as light, then it becomes an interaction of which of those forces is more powerful, I guess, in the process.
Yeah, and I guess it's also like, I know the plants can obviously respond quite differently because their roots can go one direction while the leafy parts go the other. And so I wonder if you also see that's there. If you've got, a force pointing in one direction and lights in the opposite. Yeah. I don't know if they're necessarily going to completely orient themselves to one, but rather would the roots move one way and the plant itself would move another, and you'd get some...
So maybe it's that the roots... Do the roots respond to gravity? I'm completely guessing now.
Yeah, biology is not my area of expertise.
Maybe the roots respond to gravity because they're anchoring it against being...
possibly.
No, but that's being blown away or ripped out, isn't it? That's not necessarily to do with gravity at all.
Yeah, you'd have to speak to a botanist, I think. But like I say, I'm pretty sure there was an experiment done where they rotated things and found that you did get plants growing in, I want to say peculiar angles, but in angles that respected the way that gravity was pulling them.
That's interesting.
So they seem to have some understanding of gravity and light.
So we don't really know if it would grow towards a downwards light source on Earth, but we think it might do.
Possibly, yeah.
Let's try it.
Give it a go.
This one says, the European Space Agency recently celebrated its 50th anniversary. What's been its biggest success? That's from Paul.
Goodness.
So my first thoughts, maybe this isn't its biggest success. I think it's played a really important part in spreading out the opportunities to be astronauts around the world. Okay. Because it used to always be dominated by the Americans and initially the Soviets, then the Russians. Yep. Now China is also a big player. But the European Space Agency, and working with those agencies, has introduced opportunities for people like Tim Peake. We mentioned John McFall that you spoke to recently on the podcast. They've had opportunities that would have been harder to come by. The Soviets had their program where Helen Sharman went on.
Sure,
I forget the name of the program now, but where they were...
The Juno program, I think?
Perhaps I think hers was Juno, wasn't it? Into Cosmos.
I think yes. That was the overall
You're right,
program.
Juno was her
That was her mission, wasn't it? Yeah.
Where they got some astronauts from other countries involved. But I feel like the European Space Agency, acting as a powerful collaboration between many countries in Europe, has had the nous and the clout to kind of push that.
And I think that was what I was also going to say, but a bit more generic than just the astronauts. I think its biggest success is that international collaboration.
Okay.
I think it's not just providing countries that don't have a human space program or don't have the ability, not maybe the size or the expertise to get involved to send astronauts, but also space in general. Nowadays space missions are incredibly complex, they're incredibly expensive, and I think every European nation trying to do it on their own would be nowhere near as advanced as we are at the moment.
Which is why we didn't do stuff like that previously.
Exactly, yeah. And I think the moment something like the European Space Agency came across, and suddenly you see, well, you know, France can provide their expertise for this element, and they're going to be working with the Germans who are going to be doing the engineering, and then we've got, you know, the Czechoslovakians that are experts in this degree of electronics, and all of a sudden, each country can contribute a small part and achieve something together.
Yes.
And I think that, for me, I think that's what the European Space Agency really excels at, is saying, here's a bunch of stuff that we can get involved in, and here's how everyone can contribute. We can get the best from every, you know, from a range of people, and do something that none of us could do on our own.
Yeah, I think that's really cool. I am going to pull you up on one technicality. Okay. Czechoslovakians, you've recreated a merger.
Oh, yeah, I have. Yeah, sorry. Yeah,
Chefs and the Slovaks.
Yes, I have indeed.
I think that's a good answer. And then, of course, they've various missions. The obvious current one we mentioned earlier, the JUICE mission that's on its way to Jupiter, is an ESA mission. Yeah. And again, that's exactly as you say. That's part of that collaboration. Yeah. Giving them more clout than the individual countries have.
Yeah, and it's also providing the opportunity. I think that's the other big thing with science, is it's not just having the ability to pull everything together, it's also having the reason to pull everything together. And I think as an agency, they can set that agenda and that goal of saying, yeah, we want to launch a really cool mission to go and explore Jupiter. And all of a sudden, then there's a reason for nations to start doing things, and then they've got that collaboration. And I know that's a really big thing, you know, constantly when we're looking at these sorts of politics, you know, I hate to bring up, you know, more politics, but things like when we went through Brexit, I know one of the strongest areas that really saw that negotiation and the pushing and making sure that things would happen was actually the European science collaboration. Yes. So there's the European Space Agency, we were very adamant that we weren't leaving that. Yeah, that was one thing that, you know, even though it was, you know, quite a distinct everything stops now, the European Space Agency membership we maintained. And very quickly, I think one of the first formal relationships back with Europe that we created was something called the Horizon 2020 program, which sounds weird and doesn't sound like what it is, but is actually the main driving science collaboration for Europe. So it's a way that
an awful lot of research, university research, doesn't it?
They fund that. They help scientists share information and data. But those were two areas that we were, you know, despite the want to separate a little bit, those were two areas that we were like, no. If we want to do this, if we want to still be really good at this and have opportunities, we need to be involved. Yeah. And I think that, for me, is what the European Space Agency really demonstrates. And then it also has cool missions. It's got amazing rockets. There's loads of other cool stuff as well, but it's the collaboration.
I think you're right, and all those come from that collaboration, as we've said, bringing extra power to those nations. Good answer. I think we've probably got time for another one, so let's take one more.
Let's see
question.
What we've got.
This is from Jack, age 8. Oh, this is an opinion question, but I like
Excellent.
this a lot.
We like opinions.
Would you rather be an alien or an astronaut?
Ooh. I think I've got to go alien. I get fascinated by learning new things, seeing how things change. And I think being an astronaut would be super fun. But a large part of being an astronaut is being a human. And I've spent more years than I care to admit being a human. And so maybe being an alien might be a different experience. We don't know of any aliens that are close to the Earth, so maybe they at all. Well, yeah, we don't know of any. You know, assuming they're out there, so maybe they're from a very different part of the universe.
So you're taking the chance. Okay, let me reframe the question slightly, because you've given a very clear answer there. I respect that. I'm not sure which I would say. I think I'd be a bit scared and probably go for astronaut. But I'm going to reframe the question slightly differently.
Okay.
You are going to become an alien.
Yep.
You have no control over what kind of alien it is.
Okay.
So you don't know what your environment is. You don't know your intelligence level. You're still going for that.
Yeah, why not? Take a gamble.
Are you going for that?
I'd like to hope that, I'd be able to understand and appreciate. And I guess maybe I'd forget all my current experiences. But I don't know. I think seeing a completely different world in a completely different part of the universe... that sounds really cool to me.
So no, I would assume by...
Are you on the astronaut side?
Oh yeah, absolutely. I would assume just by probability, what we think...
I'm going to end up as like a microbe.
Exactly, you're going to end up as a microbe, maybe a nematode, a little worm if you're lucky. But it's going to be nothing.
All right,
okay. How about reframing again? What about if you could... You still have to take that chance.
Okay.
You might have just a horrible mundane existence as a microbe, but you can do it for a day and then you can come back and you know all about it.
I mean, I think that would be the perfect.
I'd do that.
That would be super cool.
Because then you would get that learning.
Again, I think if that's the option, doing that as an astronaut or doing that as an alien, I'd still take the
alien. Yeah, I'd go alien in that case.
yeah, like I say, I want to find new cool things.
Yeah.
And being an astronaut is going to be super cool. That's not me trying to say that going into space and where is not. That's awesome. And if you've got the chance, please send me. But I think given those choice of two, I think it would be really cool to be an astronaut and experience floating around in the space station and that new experience. But the idea of being on a completely different world.
You're going for a totally new experience that we probably can't even imagine.
Yeah. That's
I'm saying I'm a bit too scared for that.
That's fair.
So unless I can control, I want to be a really fun alien that I know what it's going to be like and it's going to be a great fun existence.
Hey, being a nematode worm might be awesome.
You can tell me when you get back.
All right. Deal.
Well, that brings us towards the end of this episode, but as ever, we like to bring you ways to engage in space. This month, we're talking about something you don't need any telescope to see. You can see with your naked eye. You may have been lucky enough to see a supermoon a couple of weeks ago. I think it was October the 7th.
Yep.
But Josh, there's another one coming up. Do you want to tell us about that?
There is indeed, yeah. So a supermoon is when the moon is at its closest approach to the Earth. So it's not quite an even circle. It gets a little bit closer, a bit further away. When it's closer, it looks slightly bigger by like a couple of percent. So it's not going to, dominate the entire night sky, but it will look a little bit bigger. It's super cool. It coincides with a full moon, and this year it's very conveniently on November 5th. So if anybody's out there celebrating bonfire night, enjoying some fireworks or some bonfire toffee or whatever that people want to do, it's a really good opportunity, to avert your gaze from the fireworks for a moment and have a little look up at the moon and see what you can spot, because it will be there in all its glory, nice and full, unless of course it's grey and cloudy, which it probably will be because we're in the UK.
But hopefully, clouds permitting, you'll have a lovely chance to spot a really easy to see phenomenon. No need for a telescope, as I say. Now that does bring us to the end. As ever, we want to know what you want to know. We want to do more of these mailbag episodes, so please do keep sending in your questions. You can send those in to podcast@spacecentre.co.uk. On our next episode in 2 weeks' time, we're going to have a spooky Halloween special. We're going to be talking about all kinds of scary and spooky space stories, so be sure not to miss that one. Josh, it's been a pleasure once again.
Thank you very much. Thanks for tuning in.
Thank you all of you for listening and watching at home, and we will see you next time on Space Now.